Hello, welcome back to Coding Everywhere. Today we will continue writing our simulation program in Python. In the last video, we calculated the normal force of the ramp using Newton's third law, and then we integrated Newton's second law to calculate the trajectory of the ball. We also used Newton's third law and the collision model to resolve the bouncing from the floor. Today, we will use the same Newton's third law and the same collision model to resolve the bouncing from the right wall. I will just run this code quickly, and I will copy the algorithm for the collision from the floor and modify it according with the collision from the right wall. So we will check this time if x is larger or equal than the x of the right wall less the radius of the ball, and if that's true, we'll have x equal L minus R. So we'll put the ball on the floor, on the right wall, and then Vx will be changed to negative Vx. So we have a positive Vx, it will be negative, but we have to account for the escape velocity. So we'll add here the escape velocity. Now, if this Vx ended up being larger than 0, that Vx is equal 0. So if Vx is larger than 0, it means that the escape velocity was larger than the negative Vx. So this is captured in our collision model. Okay, so I will run the code. So we have the walls, then the ball, the ramp. Ball is sliding on the ramp, Newton's third law and Newton's second law. Newton's second law flying through the air, bouncing from the floor, and then bouncing from the right wall. This ends the coding to compute the bouncing from the right wall. Next video, I will add code to compute bouncing from the left wall. So right now it's going through the left wall. Thank you very much for watching. Please subscribe to Coding Everywhere channel to be updated whenever new videos are uploaded. Bye bye.